This is a brief tutorial video of a memory aid for memorizing the basic sine, cosine, and tangent functions of unit circle values in the first quadrant. So here we have our table: degrees 0, 30, 45, 60, and 90 degrees, and radians 0, pi 6, pi 4, pi thirds, pi halves, radians. And here we have our values, cosine and sine, for each of these common angles. Now, a technique to build this information up and not necessarily have to memorize it is a really nice pattern. So we're going to start out with sine and cosine. And next to sine, you write a little space 0, and then 1 and 2 and 3 and 4. And below that, we get cosine 4, 3, 2, 1, and 0. Put a square root over these numbers and divide the whole thing by 2. Now, mathematically, this notation does not mean anything, but it's just a really quick way to write down so that we can have the information we need. Now, as far as the angles go, this is 0 degrees and 30 degrees and 45 degrees, 60 degrees, and finally 90 degrees. So this is how you use this. If you have 30 degrees and you want to find sine of 30 degrees, should be 1/2. You go to the 30 degree column, look up sine. You get square root of 1 over 2. That's 1/2. Cosine of 30 degrees would be 30 degrees cosine square root 3 over 2. Sine of 45 degrees, square root 2 over 2. Cosine of 90 degrees, square root 0 over 2, that's just 0. Sine of 90 degrees, square root 4, which is 2 over 2, which is 1. And we get sine of 90 degrees is 1. So this will get you all of the information in this table without having to memorize it. It's just a very simple pattern. 0, 1, 2, 3, 4 for the sine row, and then 4, 3, 2, 1, 0 for the cosine row. Square root and everything divided by 2. This should help a lot in being able to get all of these values so that you can do them on a test if you don't already have them memorized. This table for tangent and cotangent is also something that's very simple to use with this sine cosine memory device. So I've rewritten it here nicely. What you need to do, for example, for tangent of 45 degrees, normally you would think of tangent, and you do need to know this, tangent theta is sine theta over cosine theta. So we would have to take the sine value of 45 degrees. The sine value is square root of 2 over 2. So we get square root of 2 over 2 divided by, and the cosine value of 45 degrees is square root of 2 over 2 as well. And now that is inverting and multiplying. We see the square root of 2, the over 2's cancel. This will happen for all tangents and cotangents. These over 2's will cancel, leaving us just the square root of 2 over square root of 2, which is 1. So in other words, there's tangent. Square root of 2 over square root of 2 is 1. So what is the tangent of 60 degrees? Square root of 3 over square root of 1, which is just square root of 3. There's tangent of 60 degrees. You want tangent of 0 degrees? Tangent of 0 degrees is square root of 0 over square root of 4, which is 0. 30 degrees, square root of 1 over square root of 3. Now, the square root of 1 over the square root of 3 reduces to 1 over square root of 3, but then that you can rationalize the denominator and get to square root of 3 over 3. So that one takes a little more work to get the value in the table, but 1 over square root of 3 is very commonly used as well, and if you're not done with the problem, you don't have to rationalize yet until you are, so you can use that value instead. If you're doing cotangent, just make sure you're doing the reciprocal, doing cosine over sine. So for example, for 0 degrees, cotangent would be square root of 4 over square root of 0. Dividing by 0, that's undefined. 30 degrees, cotangent, square root of 3 over square root of 1, which is square root of 3. 45 degrees, cotangent, square root of 2 over square root of 2, 1, etc., etc. So this which is very simple to create. Can get you sine, cosine, tangent. It will also get you the reciprocals, cotangent. If you wanted to do cosecant, you do 2 over the square root of these numbers and then rationalize or whatever else. It's a very nice tool, and I hope this helps.